you are asking for trouble when you do not provide proper drainage of water from off the road. That is the sure way to destroy a road surface. The water must run off the surface so that the road is kept free of water. When it settles, it will soak. And especially if you don't have the right gradation of material, it is going to develop into a pothole.
Densil, we have suffered the worst hurricane in over 170 years, a catastrophic loss for Jamaica. Practically all areas of the county of Cornwall are in ruins. Tell us about yourself and what makes you qualified to speak on the rebuilding of Jamaica after this catastrophic hurricane. Over to you, sir.
Okay, thank you very much. I am Densil Buchanan, graduate of University of the West Indies with over 40 years experience in the building industry, both infrastructure work and building structure. Structural engineer is my specific vocabulary. And I have had experience working with, in the first instance, the KCC, where in the 80s, we had to do a lot of road maintenance in the various sections of Kingston, Halfway Tree, going up to Arthurwind Drive, Old Oak Road, Woodpeck Avenue, across the city in general. So I have a road experience which I can lend to the country in terms of providing advice, how to quantify the work to be done, and to do the actual engineering work. I've had experience also working in the Alcoa Minerals of Jamaica, where we did a lot of parish road deviation, public road deviation along the Mucker to Thompsontown Main Road, building of subdivision. My position at the KSAC in the 80s was executive engineer design, which was responsible for the design and supervision of roads, gully basins, solid water in various parts of the country, Tivoli, Salt Lane, and other areas. I then moved to Alcoa Minerals of Jamaica in the capacity as, first of all, I was a resettlement civil engineer responsible for relocating vendors from our bauxite land. So we did quite a few subdivisions: Hasburn Farm, Denby Crawl, Shekels Pen, Moko, and other areas in Moko. And as a chief mine planning engineer, it was my responsibility, our portfolio, to not just resettle people now, but to ensure that the quality of bauxite which we were mining were of adequate and good quality, and we ensure that people were satisfactorily relocated. There was a policy where if you have nothing, you get a minimum of a one-bedroom, which had the facilities of kitchen, bathroom, and living space.
So does this mean that they were living on lands which they didn't own?
Well,
when you say they have nothing?
When I said they have nothing, meaning the buildings that they were living in was, in some instance, were next to nothing.
Got you.
But we would ensure that they were provided with a good solid structure, no matter how small it was. Okay. So I have been very experienced in providing resettlement buildings. Also ancillary structures. Apart from the house, there are also ancillary structures for the animals that we provided as well. Okay. The infrastructural work was very extensive. It includes roads, design and construction, bridges, built several underpass, overpass, because as you can appreciate, where the public space meets the private company, you would have to provide grade separators so that they can pass freely. So we got involved in with what we call at that time Armco superspan bridges, which were as much as 42 feet wide by probably 30 feet high, so that our trucks could pass underneath or pass over. We designed the roads, as I said, so that two Armco or two Wabco trucks, huge trucks, could pass on the road. So you know that road would have to be no less than about 40 feet wide so that both trucks could pass. We designed the drainage to provide proper drainage so that water would flow down into the gully, and the road surface was always kept free from any water with proper slope, proper geometric conditions which was necessary. So that was Alcoa experience. And I told you about the subdivisions which we built, the various subdivisions to relocate those people. So it was bridges, subdivisions, housing. That was our.
Okay. Any other experience?
I left Alcoa sometime in the 90s, and I moved on more into consulting engineer, where the design of reservoirs and water retaining structure. For instance, one specific project was Roaring River. We took water from Roaring River to Darlistan, and the treatment plant was positioned at Roaring River, and over 7 miles of pipeline, about 14 inches diameter. Water was conveyed at first to Witton substation, and then a little higher up to Caledonia, and ultimately to Darlistan, where the water was stored in a huge reservoir, about 500 cubic meters, and then we gravity feed it down to the areas that people needed, in a distribution system. That was their experience. Okay. So I have that experience as well. In addition to the reinstatement of the road, the 7 miles along the Darlistan road down. So you have to reinstate those roads using asphaltic concrete in certain areas or double surface dressing. And of course, not to talk about the curbs that we have sometimes. You have to build what is known as truss blocks to contain the pressure, that heavy pressure with the water coming down and turn around the corner. You would need some heavy truss blocks. Mm-hmm. But that was no problem because, as I said, my first vocation is structural engineer. Okay. Yeah. I then move on from that project, and I work with the Ministry of Health, where we provide, my portfolio was advisor to the minister, where we provide for the health centers, and more specifically, Kingston Public Hospital. The design layout was done by me specifically, and we had various health centers under our watch: Rocky Point, Bethel Town, and other areas, Santa Cruz, right across the island. It was my portfolio to provide the services necessary and to advise the minister, both in terms of budgetary matters and engineering work. I subsequently was invited by the government of Botswana to work in the Ministry of Land and Housing to provide infrastructure right across the country. And I work in the capacity as technical director, head of the Department of Technical Services in areas such as Kasane, the second city of Francistown, the first city of Gaborone, and Labotse, various places in But it's a very interesting area because the country is 50 times the size of Jamaica. So you can imagine it's quite a large country to cover. And that's why we even had on our portfolio land boards. We had to provide services for that those departments as well. My portfolio in Botswana is that I was the technical director in charge of infrastructure development throughout the Ministry of Land and Housing. I was also promoted to work in the department as a deputy permanent secretary for the Ministry of Land and Housing. So in Botswana, I was promoted from technical director to acting deputy permanent secretary, and even acted as the permanent secretary on one occasion, in charge of over 10 departments, including my own department, which I was initially placed at. That's the Department of Technical Services, but amongst which were other departments such as Town and Regional Planning, Surveys and Mapping, Deeds Registry, and 2 longboards, amongst others. And we sometimes had to interact with the local departments that had a wide portfolio. I left in 2016, went to New York and worked as a design engineer providing services for medium-rise buildings in the areas of eastern New York. So I worked in New York designing
That is after the structural,
structural buildings, foundation and structural buildings, structural design of medium-rise buildings in New York.
In terms of human capital, you certainly have a lot to give back to Jamaica, and you are here in Jamaica now. So we're going to ask you to tell us about the recommendations that you would have for short, medium, and long term, the measures you would take to help with the rebuilding of Jamaica, especially in the areas of town and regional planning.
The experience of Jamaica with Hurricane Melissa has put us in a position where we need to rebuild the services and the roads and the infrastructure with the proper drain, the proper channel, and using the proper material, with the right aggregates. Because most times we tend to use what we call marl, and the gradation of that material is not the right size. You need more of anywhere from, I would say, half-inch size material, 3/8-inch aggregates, and then you roll that and compact that in as much as possible. If you use smaller gradation, as I said, as marl and so, it will not last, especially if you do not provide the service of the right channel to keep the surface of the road clear when it rains excessively. Water should always be able to run off from the surface of the road so that there's no soaking of that finishing course material at the surface, because that will essentially destroy your road. We normally, as engineers, design for a storm of 1 in 2 years, which means you expect flooding in 2 years. When you experience a flood of a 1 in 50 or 1 in 100 years, that is a massive flood. And you cannot design the road to carry that level of water. So most times what we do, allow that water to run off, and thereafter you are able to use the road. So a flood condition like what Melissa brought to Jamaica, it would have been very difficult to prevent flooding. But you as an engineer, or as engineers, know that you allow the road to carry the water for a certain period of time. It runs off to the gully or runs off to the area where then the road surface can be free again. That's how we design the road to act as a channel.
But the roads we have here, especially down in the west, those roads have been completely destroyed. What do you do or can you do to mitigate the likelihood of that kind of destruction?
Well, as I said, yeah, in some instance, those roads could have withstand the flooding, where when it runs off, the surface is still remain intact if you had the proper channel for the water to run off continuously until the surface is drain free. So roads should be built with adequate channel, adequate material from the base course, the gradation of the aggregate between 3/8-inch and 1/2-inch material size, and then you roll that in to make it be a solid surface. And then on top of that, you put on maybe another 4-inch layer with similar gradation of material, roll that in, and so you get a solid surface. But most times in Jamaica, we tend not to use the right material at the right gradation. Those material, when I said right gradation, it had to be properly sieved, and the dirt and the fines are completely removed. So you're ending up with just the right gradation between 3/8-inch and 1/2-inch size material. The finishing course material, it is preferably again to use 3/8, 1/2-inch, and so you have what is known as with the tar, a double surface dressing. And then if you can afford, in certain areas, you would provide the asphaltic concrete and You know, you use your textile material to help you provide adequate finishing.
Many of the roads in Jamaica, they do not have culverts or a proper drainage to rapidly move the water away to prevent the erosion of the roads. What
So
recommendation?
you are asking for trouble when you do not provide proper drainage of water from off the road. That is the sure way to destroy a road surface. That is a sure way to destroy your road without the proper channel, drainage channel or culvert. The water must runs off the surface so that the road is kept free of water. When it settles, it will soak. And especially if you don't have the right gradation of material, it is going to develop into a pothole.
What recommendation do you have for those who are living in low-lying areas, like the whole area of the county of Cornwall? You have Santa Cruz, would you say Elizabeth? You have Westmoreland, you have Hannibal, you have St. James. All the area there is flat.
Mhm.
And that is why they were impacted so severely by the hurricane.
Mhm.
What recommendation do you have for the rebuilding of homes in these areas?
Okay, Melissa provided us with a guide, because one guide that engineers use, you always go out and the people who lived in certain areas, you always inquire what is the flood level that they have experienced historically. And if you are able, then you design so that you can withstand that flood level in the future. If you know that the flood has come to like 5 feet, then it is preferable not to make your contour only 2 feet, because you're going to be flooded
again.
Right. But sometimes it is not possible. Like as I said, with a storm like Melissa, you are going to get some flooding, and it's very difficult. But on an average or statistically, you can provide houses on stilts so that it is elevated from the level at which you have experienced previously. That is how you treat with a situation where the land is flat and you want to elevate the building above a certain point so that it is somewhat protected and you do not have a frequent flooding. But where you have in something like Miss Melissa, it is going to be difficult to protect houses above a certain or below a certain elevation.
So what recommendation do you have for those who, as I said, who are rebuilding? What is the size of the columns, the still, whatever you are building to secure these homes?
Right. So it's really the contour map. You look at the contours of the land and you see how possible it is to drain the water away. And over a period of time, if you are able to provide drain with the right slope, with the right geometric condition, you might be able to protect the buildings in that area, in that zone.
The majority of the persons across the West, they have lost their roots. What recommendations do you have for them to protect them in the future?
I recommend two solutions. Those who can provide more concrete roof in certain areas, I would recommend that be done. But that's one known way of preventing a blow off. But roofs that we have where you have zinc, aluminum sheet finishing, timber roof in general, there's a method where you use hurricane twisted strap to ensure that the roof is not blown off willy-nilly. Those straps are much stronger than simply nailing at the joints, at the ridge board and at the eave level. You provide hurricane twisted strap at that level so that it is better anchored when the wind blows. Because there's a certain force with the wind, which the wind is going to come with. And the engineers usually calculate that force. And therefore, you might be able to position those straps at every rafters on ridge, and rafters at the tail, rafters and heave, or every other rafter. So what it means, rafters are usually placed about 2 feet apart. So if you're positioning at every of the rafter, it means that you will be placing the twisted straps 2 feet apart. But if you're placing it at every other rafter in cases where you have done your calculation, it means that you'll be placing them at 4 feet apart. So it's that kind of technique we use.
How about anchoring on a shear wall?
And a shear wall is good to prevent toppling over. And so at the base, you usually design, there's usually a shear force which we calculate, especially with buildings that are multi-story buildings and medium-rise building. You usually design so that the foundation can withstand. Either you use a raft foundation or a foundation that is placed 2 feet, 3 feet, 4 feet deep in the ground. Yeah, that is how you would mitigate, blowing over, and that even help with earthquake.
Okay.
As well.
Let us talk about the building of a subdivision in a flood-prone area. A lot of the lands nowadays are being used for housing developments. What advice do you have for those developers?
Provide berms, dikes, and structures that will assist in protecting the houses during excessive rainfall. Those dikes or those berms simply is built more around the area so that it prevents flooding to that area.
What's the size of these? Because I've noticed that some of these walls, they collapse during the hurricane.
Which means that it has to be structurally designed, properly designed. There is a principle which we call the retaining structure, where a retaining wall has to be designed from the foundation up. Do you provide reinforced concrete or do you use stone wall with the adequate embedment into the ground? That can be done, but it must be properly designed by a structural engineer. Sometimes we just go there and build as if we are expert in our department. And the fact of the matter is that you may need a gravity wall, what we call a gravity retaining wall, instead of a simply reinforced concrete wall. Gravity retaining wall by using stone wall, where it's very thick at the base and thinner at the top. And so that would help to protect the area, the scheme in which you build. But you have to assess the soil condition is very important, because is it clay or is it rock? Is it igneous rock, sedimentary rock, or metamorphic rock? You have to analyze and see whether or not the slope stability is also very important, because during rainfall, that wall can tumble over if it is not embedded sufficiently in the ground.
Based on the type of rocks?
Based on the type of rock. Or based on the type of soil condition. Yeah.
So in an area where it is swampland, like what they usually term as agricultural land, what kind of foundation do you would you recommend?
Ideally, we use like raft foundation. What we mean by raft foundation is like, it could be a concrete of 4 inches thick with a mat inside of the concrete over the surface as the base, as the foundation, rather than digging on the perimeter, the periphery of where the walls are going to go. You put a raft over the entire area, so it acts more as a flotation, as if it is bearing the thing like you're on the sea. And in that case, it serves a good purpose and guard against what we call differential settlement. And so that kind of foundation, raft foundation, is usually maintained on where the soil is very weak, and you want to ensure that you sustain a good bearing capacity. You up the bearing capacity by having a raft over the area that you're building.
Tell us about the water supply system that we have here in Jamaica today, and what we can do to ensure that we get water in the future, having had this devastation.
Water supply system, it is always ideal to dig to about 2 feet deep to bury the pipe when you're running like a water scheme along the road, and where the soil is not too hard. Where the soil is very hard, you can use jackhammers and bury those pipes. That is how it is supposed to be done, where you bury the pipe, and above it you provide a sandy material above the pipe, about 2 feet, and then you finalize with earth, to bring it back to its regular condition. But there are cases where you might not be able to go as deep down, as I said, 2 feet is the standard depth that we use for pipe laying,
In
especially.
Jamaica today.
Yeah.
Mhm.
But in some cases, what you do is use galvanized pipe instead of the plastic pipe down in the ground. And that galvanized pipe will mitigate against certain condition above surface.
You have some development schemes where there is water in the complex, but most of the community members or households, they do not get water. Or they may get it in the morning and they don't get it in the evening. And when everybody comes in, the scheme, you have a limited flow of water. What is the cause of this and how do we prevent this from happening in the future?
It means that water pressure is too low because of a great demand. Usually you design the water flow based on the demand of residents. How many residents do you have living in that area? And therefore you design the flow is usually based, the flow Q is equal to the velocity that you're going to get with when it is flowing, the velocity, the area of the bore, and of course, as I said, the demand that it's being drawn.
So it has nothing to do with the size of the pipe.
Well, ultimately, it determines the size of the pipe. If you provide too big a diameter of pipe, right, sometimes you're not going to get the flow coming out, you know. And if you provide too small a diameter to get that flow, what it means is that you won't be able to sufficiently.
So the engineer has to design
the
pipe.
It's a design, yeah.
According to the amount of persons living in that community.
And we term the demand. What is the demand and what is the pressure you can get? What is the demand?
Mm-hmm.
The demand is based on the number of persons that is going to be requiring water at a specific time.
Mm-hmm. We've always had challenges in these areas where there is limited water supply. How do you improve conditions and safeguard against drought in these rural communities?
You could do what is known as rainwater harvesting, and you build a phenomenal network from each house. You have gutter system where the water flows into a central tank, and that same water can be pumped to the various houses when in times of need. So you initially convey the water from the roofs of those houses into a central tank, which then subsequently can be pumped
back into the homes. Okay. So is it that each house must have a concrete tank in their backyard, or
one central tank could be required, and you have a proper network of gutters that leads the water into that central tank, and in times when it is needed, it can be
harvested
right to the different homes with their pipe and a pumping system. It has to be engineered and designed, though, properly designed.
Yes.
Because bear in mind that the contours of the land would dictate how you can run your pipes. And of course, where you may have driveway, the driveway might be passing certain point, and that water system would have to be, our pipe system would have to run under the road going to it has to be properly designed by the engineer. But yeah,
before construction, yeah, the ground.
Yeah, definitely. You would look very much so at the contours of the land and provide a pipe network that can both have inflows into the tank and outflows of that tank.
On that topic of groundwork, let us jump into electrical connections. What do you recommend? I mean, we have light posts, both concrete and wood, all over the place, and we lost electricity for. We don't know when it will return to some communities.
I think the Jamaican government should start thinking about where we can provide services on the ground. Instead of having light posts elevated above ground, you run underground wire to provide those services like they do in other countries. Because what it means is that when you have a natural disaster such as a hurricane, you would not have a light post to worry about because you would have the channel underground. And the wires would be run in those channels to the different homes. And it is providing the service. It's just that it's more expensive to excavate and put the wires in the services in those channels. So you're providing service through the ground to the homes instead of above ground to the home.
Okay, so you have a separate wiring system below the earth.
Yes, and you would see no light posts because there's no. And then if the storm comes, there won't be any. But you could
going
have to,
down of these posts.
Right, but that would have to be properly done so that
designed,
properly designed so that, because you're talking about wire in the ground, so it would be wire encased in channel and below ground. And then when you come up in the house, you come up, instead of coming from the top, you come up from the bottom.
Okay. It is not a part of the recommendation for the government at this time. But can a man who is starting the development of, say, on 50 or 100 acre of land, can he go in and do this all by himself?
No, he will have to get the standard. The government will have to put out certain standard, as there is with how it is done now, above ground. Because as you know, you're dealing with electricity. And if the standard is not properly met, you could have a lot of electrocution. You understand? And one difference is that it would be absolutely necessary to know on paper on where the wires are being run. As against, you can see it when you run it on light posts above. But can you imagine 50 years from now, you don't have a diagram which shows where the wires are run, and you go there and you are excavating, and you suddenly buck up on electrical wire. So there would have to be certain standard issued by the government. Now that is very difficult because there are other countries that are doing this. And one thing, it would be much more expensive. The building would be much more expensive. Will be expensive because you're going to have underground cables.
What about the sewage system here in Jamaica?
We use waste stabilization plant where you have a lot of land space to treat the sewage, where you basically dig the ponds and you allow water to treat the sewage with the atmosphere. But as I said, you have to have a lot of land space to provide treatment of that sewage.
Do we have that here in Jamaica?
There's a system somewhere in the Negril area, and somewhere there's one in Montego Bay, somewhere along the Howard Cook Boulevard. One was built.
How does it work?
The waste, what we call waste stabilization pond, you have two ponds. You have one that accepts the sewage into it, and it stays there, and over a period of time, by virtue of the atmosphere and certain chemicals you may have in it is treated that way. And then the water, what you call the effluent, flows over into the other pond. So you have the sediments from the solids, which we call, as I said, the waste stabilization pond, goes into the first pond, and with the atmosphere, it stays there, and over time, it breaks down. And then the water from the effluent from the first pond flows over into the second pond, where you will probably use some kind of a chemical to treat it. That is the waste stabilization pond method.
And so that at the end of it, you get water.
Yeah, you get water which you can use. You can either treat it with chlorine or so, disinfect it, and maybe dispose of it out into probably the sea.
Or use it to water your lawn and the garden.
Yeah, right. And then you have the other system, is the mechanical system, where the sewage, it goes into a plant, filter plant, and it is treated in that plant. And then likewise, after the treatment, and you have the effluent running off, you can use chlorine again to treat that effluent, that water, and it can be used to
in your garden.
Yeah.
Okay.
And of course, the system that we mainly use in rural areas is very usually septic tank absorption system, individual system. And more specifically, they also have the biodigester system. The biodigester.
Explain what that is.
The biodigester is simply a sealed tank. It's like system being sewage being treated in the domestic situation. Right, just that the tank is not sealed like in the back of your home. You'll have a sewage absorption pit sewage, septic tank, and soakaway pit. But those are not sealed. The biodigester is sealed. And when it's sealed, it means that no air can get in, and it therefore breaks down. And when it breaks down, then the effluent can run off, and all you need to do is use chemical like chlorine and render the bacteria and so harmless. Yeah, and you can even get ammonia. Is it ammonia? Methane gas from off the biodigester that you can even use to cook.
Oh, really? Interesting. But in this case, you would need enough land space to do that, or it doesn't?
No, what you need to do is to make sure that the capacity is adequate. It's not so much of a large capacity that you need. It's probably a similar thing like the septic tank absorption pit, but it's just that the tank has to be sealed.
Okay, so that's a difference.
The difference is, the tank is sealed. Nothing can escape out of it. And so that natural process takes place. And it ultimately breaks down the sewage and the effluent flows out. And then the gas, you also have somewhere where you either burn off the gas or you use the gas for domestic supply.
We all are in a state of panic right now, and the international audience, they're looking on us here in Jamaica to see how they can come and help to rebuild Jamaica. Do we have enough human capital resources to do it on our own?
Certainly we do have some of the capital, human capital, that will be required to do the quantification and the inspection and, of course, some of the engineering work. And so Jamaica should really call on the local fraternity of engineers and construction inspectors and supervisors to assist with the rebuilding of the country.
And the human capital in the diaspora, Jamaicans living in the diaspora, working in those capacities right now.
Yes, not to mention, people who have migrated to places like Botswana, New York, places. Florida, yeah. Various places. We could do a bit of help with them, with their hands. And so, without any hesitation, they should be looking for help in this regard.
Jamaicans living here and in the diaspora, including yourself with your experience.
Yeah, well, I would be more than willing to help. And as I said, the background is in structural engineering, civil engineering overall. If you're doing sewage, water resources, earth movement, drainage, those are my areas of expertise. And bridge building, most importantly.
And we also have retired engineers who have been heads of companies here as well. We could call them back out of retirement and use up their skills.
Certainly. I endorse that.
Thank you for your time, Densil. The information you have provided certainly will help us to navigate through the crisis that we are faced with.
You're most welcome, and I look forward to be a participant in this rebuilding effort for Jamaica.